The universe. Its size, immeasurable, incomprehensible, a vast, perpetually expanding object that has lured humanity into staring upward for millennia, searching for meaning in the
32
darkness.
seconds into the flight.
From subatomic particles
Three
to
liquid
ancient
fuel-made engines
galaxies,
soon will throttle back to
its secrets
72%
remain,
rated performance.
despite our best efforts, largely hidden. And yet, somehow, we think we can understand it. We claim to know how it began, how it functions, and most shockingly, how it might end.
How is that possible? How can we attempt to process something so large? The universe isn't just big, it's staggeringly, ridiculously, terrifyingly big. So big that our brains were never meant to hold it all. Events unfold over timescales so long they make our entire civilization look like a blink. But computers, they don't blink, they don't sleep, they don't forget. When we compress the universe, scale it down, speed it up, strip it to numbers, something amazing happens. It becomes manageable. We can watch the birth of galaxies in fast forward, witness the dance of dark matter, or glimpse the heat death of existence itself, all from inside a cold human server room. Ever since Alan Turing's groundbreaking Turing machine in 1936, computing has evolved at a breakneck pace. With the rise of integrated circuit, our machines cross into territory once thought to belong only to science fiction. And it is precisely this ever-growing computational power that has led us right to where we are today, simulating the most complex thing in existence. Sounds impressive, right? Sure, but also, doesn't that feel a little too convenient?
So, how does this actually work? Step 1. Gather everything. Every equation, every observation, every law we think governs reality. Pack it all up into a tidy framework of cosmic rules. Then, we feed that into a machine learning algorithm. Not just any program, a self-learning AI designed to recognize patterns, make predictions, and improve its own logic, without needing us to guide it. And this AI, it doesn't run on your laptop. It lives inside supercomputers, machines so large they could fill stadiums, machines that cost billions, machines that only a very small number of people truly can afford. Once the AI deciphers our cosmic blueprint, it generates a virtual version of the universe, digital particles, synthetic stars, artificial gravity, the full illusion. Because simulating everything at once is too much, we divide the cosmos into slices, say 100 million light years across, and then we build from there. After this, we finally run it, and just like that, the simulation begins. If it all goes well, and we hope it does, we watch our digital universe unfold at thousands of years per second, a god's eye point of view of time, space, and matter, stitched together by ones and zeros. In one such simulation, a galaxy forms before our eyes, from the moment of the Big Bang onward. Each frame, each flicker of movement represents eras, eons. The computational effort is enormous. Despite this, it still is not enough. But why? Even a scaled down version of the universe is unimaginably complex and would be impossible to simulate accurately with the vast resources that we have available nowadays. For this very reason, cosmic simulations trade focus on a very specific aspect of the universe. The one of observation might help us the most. Some focus on black holes that might not even exist. Others track thousands of asteroids, predicting whether one might strike Earth. But without the whole picture, we will never know for certain how accurate the simulation is. Each model has flaws. Each result comes with uncertainty, and no simulation is truly accurate, because the universe doesn't play by your rules, it barely tolerates them. Even the most advanced computer in the world is still just guessing. So why do we keep doing this? Maybe because it's not just curiosity.
Perhaps it's something else. Simulating the universe isn't just an intellectual exercise, it's kind of a mirror. a digital echo of something far older than us. With every frame, we get closer to something we might not be ready to find. But here's where it starts to get eerie. When we build a simulation that mirrors reality so closely, we also start to consider that maybe our reality is itself a simulation. That's not just science fiction speculation anymore. It's a serious philosophical and even a scientific discussion. Think of the simulation hypothesis proposed by Nate Bostrom. If simulations become advanced enough and widespread statistically speaking, it's more likely we are inside one than outside. Maybe we are not just watching the universe. Maybe the universe is watching us. But for now, our universe fits in a box.